the matrix. The matrix is the table of elements or items which has a subscript index, which means that this element stays on the first row and first column of matrix. This matrix has dimension m on n. That means that this matrix has m rows and n columns. So we notice that I is number of row, j is number of column of the element a, I, j. If m is equal to n, matrix is called square matrix. The particular case is an identity matrix. Identity matrix has units on the main diagonal and zeros on other places. Another case is zero matrix. Zero matrix has all elements equal to 0. If we replace columns in the matrix A on rows and the rows on columns, the resulting matrix is called transposed and is recorded as A with a superscript or A with superscript T. For example, if A is equal to this matrix, then transposed one is equal to this. You may see that rows became columns. The second example is a matrix of the dimension 3 on 3. It has 3 rows and 3 columns. So the simple way to make transposed matrix is to replace symmetric elements. 2 we put here and -1 we put here. 3 we put here and 4 we put here, and replace 7 and 5. So if we have two matrices A and B, we may summarize them. We have to summarize elements of A and B for make their sum. When we subtract two matrices A and B, we have to subtract their elements. When we multiply by a number, we have to multiply each element by this number. Okay, let's see some examples. The first one. When we summarize two matrices A and B, we have to summarize their elements. 2 plus 3, 3 plus 8, 6 plus 7, 5 plus 2, 1 plus 4, and 2 plus 6. You may calculate these operations at home. The second, when we multiply the first matrix by 2 and the second by 3 and subtract results, we have to multiply the first matrix by 2, all elements by 2, and all elements of the second matrix by 3, and then subtract results. Okay, this you have to do at home. The next operation is matrix multiplication. What does it mean? When we multiply two matrices, we have to see that number of columns of the first matrix have to be equal to the number of rows of the second matrix. Then, how we multiply two matrices? We have to multiply each element of this row and this column, and they then summarize answers. -1 we have to multiply by 2, 2 we have to multiply by 0, 0 we have to multiply by 1, and then summarize results. For the second element, we have to take first row and second column. Why? Because in the answer matrix, we have the element with the subscript 1, 2. This is prompt for us. 1 and 2 says us that we have to take first row and second column, first row in the first matrix and second column in the second matrix. So -1 we have to multiply by -1. 2 we have to multiply with 1. 0 we have to multiply with 1. Then summarize results. So when we multiply matrices, the following cases are possible. First, product of A and B is undetermined. When the number of columns is not equal to number of rows of the second matrix. This product is undetermined. Second case, when product A and B is determined, however, our product of A multiplied by B is not equal to product of B multiplied by A. You may calculate this product of these matrices and check whether this product is equal to this product when we replaced them. This action you will do at home. The third, there exist such matrices A and B for which product A by B is determined and A multiplied by B is equal to B multiplied by A. For example, you may check this product of these two matrices and check whether the answer is equal to replaced product. So matrix multiplication is non-commutative but associative. It tests in general case when A multiplied by B is not equal B multiplied by A. This property takes place. We may replace brackets and the answer will be the same. Fourth, there exist such matrices A and B are not equal to 0, but their product is equal to 0. For example, you may check by calculating this product. Economical problems citing to actions on matrices. The first. Let's 3 types of goods delivered to the store in the first week: refrigerators, TVs, and washing machines. Following vector x1 is equal to 10, 12, and 8. Means delivery of 10 refrigerators, 12 TVs, and 8 washing machines. If these items are delivered in the next week on the quantity x second, which is equal to 5, 8, and 10, find out the total number of items. How do we consider the solution? By the rule of the matrix addition, the total quantity is equal x1 plus x2, and we may see that the totally they're delivered 15 refrigerators, 20 TVs, and 18 washing machines. The second example is number of 3 types of products purchased on the market within 4 weeks: meat, rice, oil, is given by the matrix A. Their cost is set by the matrix B. Find out the cost of 4 weeks to purchase these products. We have to notice that for this we have to multiply A by B. So, costs of the first, second, third, and fourth weeks mean elements of matrix C, and the total costs are equal to 22,000, for example, dollars. Thank you for your attention.